So indeed, I will be talking about functional and reactive UIs. The only problem is I'm not really expert in any of this, so I'm really sorry. In fact, I'm not really expert in anything. Like my adventure with programming started pretty early, but during this talk, I will describe how it all like combined into what I will present today. And the idea is here to share my excitement about a specific technology and how ideas flow through time. So before I start, I would like to make a short survey. Could you tell me who invented the term object-oriented programming? Any guess? Sorry? Yeah, exactly, Alan Kay. And do you know the definition of what is object-oriented programming? Anyone?
Data together with the behavior.
What? No? Exactly. Exactly. It's about message passing. So this is the definition. Objects communicate by asynchronous message passing. And could you, based on this definition, give me an example of object-oriented programming language? Okay, that's a good one. Exactly, Smalltalk. Any other? Because I don't know any other object-oriented programming languages, according to this definition. It's pretty interesting how like terms change and they don't mean what we think they mean. So I'm Zaiste, and I ran a company, a small company based in Paris called Nukomeet. I'm also running a conference called PolyConf. I highly invite you to participate, to join us. We opened our CFP. And as I said, I will be talking about my story and my adventure through programming through a very specific angle. But before I start, I would like to thank you, Michał here, a good friend of mine who is running this conference, for the invitation. And I would like we give a round of applause for this wonderful conference, Lambda Days. Okay, so everything started in 2005 in my case. So up to this year, I was doing mostly Java, like Java. I was programming in a framework called Struts 1. Do you know this framework? It's a very old one, and in 2005 I moved to Paris, and I was working in a laboratory. It's a laboratory which does things related to artificial intelligence called LIMSI, and I was doing mostly Python. I didn't really knew a lot about functional programming. And this was the year I got exposed to this the hard way. So when we think about functional programming, it's like a lot of things. The definition is very, it's hard to give an exact definition of functional programming. For sure, we could say that functional programming is about functions. So functions are like first-class citizens in functional programming languages. We can use them. We can pass them around, we can use them as data type, they can be returned, etc. But functional programming is more. It's also something like laziness, it's something like referential transparency, pure functions. We can also say that immutable data structures could be part of the definition of functional programming. So my adventure started in 2005 with a language called OCaml. And I had the pleasure to be tutored by a guy who contributed to the development of this language, Marc Pouzet. And this was very hard. I didn't really understand anything. It was like the worst period of my life. I couldn't understand anything in OCaml. But eventually I returned to this with much of the pleasure. So OCaml is a part of this language. Is a part of the family of ML languages. It's one of the these are like the oldest languages, the family of the oldest languages that exist, and it was developed in 1970 by Robin Milner. So ML has a lot of influence today still. So for example, Haskell or Elm recently, they all like take from this heritage, we could say. when we think about UIs now, what is really a UI? How we can think about this? So UI is a way for humans to interact with computers, and we can think about this as a way where both sides, like humans and computers, they are mutually observed. They observe each other and they react to each other. There are some approaches how we could formalize this this thing. So, for example, in 1970, again, very old stuff, there is this guy, Trygve, who invented the term, who proposed the architecture called MVC. We all know, and we still use it. This thing was introduced into a language called Smalltalk 76 when he visited Xerox PARC facility. So what is really MVC? So MVC is a way to bridge a gap between digital model and mental model. It's a way to interact with the machine and for the machine to show us, to interact with us. So MVC is something like this. We have a user, and we have those three entities, three things. There's a controller, which interacts with the model, but may also interact with the view. There is a model which interacts with the view, and the view which shows the things to the user. But when we think about MVC and user interfaces programming, we usually think about programming which is about callbacks, attaching functions to events. And this way of programming is not optimal. There are some flaws, there are some problems with this. For example, the control flow is scattered. It's not really centralized. There are things like shared state. We don't really know how to manage the side effects. And on top of that, it's not coordinated. The problem is coordination in this case. So this sounds like functional programming could help here. So what functional programming could offer for UIs? The first thing, recent thing, which comes to mind is React, this rendering engine, this rendering library. And I think we could agree that React made functional programming more popular in the mainstream. React is a very simple idea. It's declarative, which means that we can build simple and straightforward UIs. We define how our UI looks like, and then we change it entirely. So we can think about UIs as some sort of a function of the data, of the state. And this is the functional foundation for building UIs. Very simple idea. So let's imagine that we have a function which operates on the data, on the state, and this generates a view. The data changes, and we have another view. So how we could manage those different renderings of the view? We could say that we are only interested in the difference between those two views. And this is another idea. This is another thing which is very common somewhere else. For example, when we think about source code management, we have Git. And Git is also about managing the difference. So we just carry about the changes. And we could say that we have data, our central point, which when the changes happen, and this is propagated through some intermediary layer, which is called virtual DOM. And then once we know what we want to change, we apply this to the external world, to the our DOM. But this quickly becomes very complicated, right? Because we think React, but React is only library for rendering things. We would like to also do other stuff. So we need to introduce some kind of architecture. We could use Redux, we could use other Flax architecture, but this is something maybe not new, but there are a lot of new concepts here. For example, we started with rendering, we started with simple declarative approach, but here suddenly we have something like actions, action creators, dispatcher, store. This is not very familiar, right? We all, like, I believe, most of us comes from MVC world, and then we have new concepts introduced to us. So this is some kind of difficulty, additional layer of abstractions that gets, which is being repeated and repeated and repeated. So reactive programming to the rescue. What is reactive programming? Reactive programming is a programming when we think about interactions in terms of data streams, asynchronous data streams. And we have functions which allows us to combine those data streams into another data streams. I think most of us got exposed to reactive programming pretty early. I think it was probably the first way of programming, like one of the first one. And it's through a spreadsheet. So who used a spreadsheet in his life? Yeah. I think, well, everyone, probably. So a spreadsheet, we could think about a spreadsheet as a reactive programming tool. So let's imagine, let's take a cell, right? We have a cell, and this cell represents values that can change over time. And what's interesting in this model is that we can take a formula, okay, and we could put this formula into another cell, and we don't worry about how this is propagated through the spreadsheet. We know that when we combine two other cells into like one cell with the formula, it will work. And this is basically reactive programming. We have things like cells, which we can observe, right? So we could say they are, without any formal definition, these are things that are observable because we observe them. And then we have another cells like with formulas, and we can observe them as well. And things happen when we change a formula, or when we change the cell with the data. Everything gets propagated. But let's stop maybe for a moment, and let's think about like how things can depend one on another. So let's imagine we have two entities. Okay, we have entity A and entity B, and there is kind of dependency between those two entities. And let's examine like two possible ways. The first one is passive way of like passive dependency, which means that this A thing is responsible for changing something inside the B. So this is passive because B is not really responsible for itself, right? It's let's maybe take an example. We have a network request happening. A is responsible for like doing a request, like external request, and there is B, which should react to this. There should be change inside the B. So the first thing, passive way, would be that it's A, when the request happens, A changes B. But there's another way, which is reactive, which means that B can observe A, and when something happens in A, B will change itself. So what's the advantage here? The advantage is it's a better separation of concerns. A and B are only responsible for themselves. So I change myself because something happened externally. There's no one who changes me. Another thing is that it leads to a better encapsulation. So we don't have to provide a way, B doesn't have to show or make its API public. we don't have to it doesn't have to provide a way for the interaction. It can like manage its own state on its own. So when we think about reactive thing, it means that we have entities which are independent and self-contained. So now let's like extend this abstraction a little bit further, and let's not only talk about like method calling between entities, but let's say we have values that change over time, and we have mechanism to like retrieving the data and transforming the data streams, and we have also mechanism to be notified about changes. So when we think about this, values over time, and we'd like to make it like first-class concept, we could say this is observable. So something which can be observed and that changes over time. So observable is a very simple abstraction, and it's like putting together two design patterns. The first one is about observing things. So we get notified about when something changes, but the other one is about iterating. So we have functions that allows us to transform those sequences into another sequences. And another thing is that if we make this a first-class concept, we don't have to worry about like low-level details like synchronization, threads, concurrent data structures. It's not our problem. Like with the spreadsheet, we just think in the terms of values that changes over time. So this is marble diagram. It's a way to represent an observable. I won't dwell too much on this, but usually when you start with reactive programming, it's a nice way to get to visualize things. So this model, observable model, allows us to treat streams asynchronously. And on top of that, we can compose things. So an observable is a lazy event stream which can have 0 or more events, and it's also an abstraction which allows us to tell us, did it finish or not? Advantage of this approach is that it allows us for a better asynchronicity. We can do asynchronous things more easily. So let's imagine we have a bunch of tasks, and then we are in there's an environment which allows us to treat them in parallel. So the advantage here is that when we combine those things, it will take as long as the longest task, because if we take this assumption that everything happens in parallel. So this abstraction, observable abstraction, it's declarative because it tells us, it responds to the question what and not how, because we don't worry about the implementation details, we don't worry how it's being transmitted, like with the spreadsheet. We only define how it should look like. Another thing is that it allows a simple composition. So we have one observable and another one. We can combine them, and we can have another as an input, output of like combining two observables can be input to other observables, etc., etc. This is also a nice unification. So in JavaScript, for example, we have a lot of concepts like promises, we have callbacks, web workers, WebSockets, and all that is it's like a different API. We have to interact with that. We're using Observable, we can combine it into like simple unified package. So when we talk about implementation, there is this reactive extensions project, and it's a way, it's a collection of libraries for different programming languages. So RxJS is an implementation for JavaScript. Let's take a look at an example, very simple example. And this example allows us to detect if there are double clicks on our web page. And nice thing about this is very concise expression. I challenge you to write it into regular JavaScript, and I think it will be much longer. So as you can see, only 4 lines. We use things like map and filter. So let's maybe start from the beginning. So first we just take clicks and then we buffer them. So we compose clicks into sub-arrays. And we say that the window, the window for these clicks to form an array should happen after 250 milliseconds. And then we just map over those arrays, and we just detect if they are 2 clicks. It's very simple. It's very declarative. OK, so we went through functional programming, building UIs, and then we talked about reactive programming. And, well, we could maybe combine all this into something like a nice package, which will allow us to build UIs using JavaScript with reactive programming with this functional approach. And this is why I would like to, as I said, share my excitement, my small excitement. It's a library called Cycle.js, which does exactly this. So this is a functional and reactive framework, UI framework, which allows us to build interesting application. The first thing is very concise. Both the framework and the applications we build with this. It is extremely simple API. It's only one method. And this is how it works. So at the beginning, we talk about human-computer interaction. And this is improvement over this slide. So we could say that between computer and us, like humans, for example, we have screens. We have input devices such as mouse. And we have senses. We can, for example, see the screen, or we can click a mouse or type on the keyboard. And this is some sort of cycle. So for example, when I click on the mouse, computer can take this information and change the display so I can see it. So there is a cycle coming in. And we could think about this. We could think about this as a function, right? We have input from the external world, and then computer generates the output. And this is some sort of dialogue. And another thing is that this function, this computer function, looks like a pure function. Okay, we take input devices, we do some sort of changes, and then we produce the output things. So let's imagine that human is also a function. Okay, so he has a senses, or she has a senses, and she, for example, can do some things, like click on the mouse. This also could be treated as a function, maybe pure one. So UIs could be, we could imagine UIs as cycles. And it seems this is a very natural way to expressing this. So in Cycle.js, this computer function is called main. And this is pure function. And it looks like this. We take an observable, which is a stream of user events. And then we could extract from this what we want. We could filter things. And then we could transform this into some sort of UI. When we talk about pure functions, the input for this function would be sources. So we could, for example, take DOM events as a source or other things. So sources is the input for our main function, our computer function. And these are read effects from the external world. And then there's another concept in Cycle.js called sinks. So sinks is the output. So for example, we do something on the web page, and we expect that the view will be rendered. And this is sync. This is the output of it's a write effect to the external world. So between us and the computer, there is a driver. And a driver is a way to push side effects to the external world. We push the side effects through a driver to the external world, but we stay pure while building our UI. And there is this like pattern, or maybe a small architecture introduced in the Cycle.js called model view intent, where we think about things happening in main. We have the main function, and it could be split into three major parts. So the first part at the beginning is the intent. So it's like processing the input from the user. What's the intent? What she wants to do. The other part in the main function is the model. This is where we manage our state. And then we have the view. So view reacts to the changes in the model and generates a new view. This is very composable, as functions are and pure functions are. We can not only use, we don't have to use one function. We can split this one main function into parts, like several parts. Which one could be also divided into intent, model, and view. Okay, so let's check a small demo. So this is the first example. It's a very simple function which takes an observable, which generates events each second. There's a new event, and we map those to a node into our DOM. So basically, how it looks like is, if I just so this is what it does. So let's go back maybe to the example. Okay, I lost my mouse. It's extremely simple. I challenge you again to do the same with your favorite programming language.
Yeah, those are not alternative libraries, but you are using both, right?
Yeah, yes, I'm using both. I'm using a Reactive extension, and I'm using Cycle.js, exactly. So let's maybe take a look at another example. This example takes the input. So we have our sources. So this is like the things that happen in our DOM, and we just select through them. We just say, I'm only interested in those happening like for specific things. And then I map those events, and I'm extracting the value. I'm starting my stream with a simple, with an empty string. Then I map each thing to another piece in my DOM. And as a result, I have this, where's the mouse? I have this. So again, it's extremely simple. Let me go back to, we have only, 8, 9 lines, and we can reproduce pretty interesting behavior. So to sum up, we built our UI using pure function. It's a referentially transparent function over observables. We take inputs from the external world, we do some processing, and then we produce an output. And all side effects are pushed outside of this function through drivers. And our approach is reactive. So when we splitted this main function into 3 parts, intent, model, and view, we could say that intent observes the user, right? Because it waits for her interactions. Then we have a model which observes the intent. The view observes the model. And finally, the user observes the view. there are some limitations as well. This is very of this approach. I recommend you to check them out, and I think that would be all. Thank you. So any questions? Yes?
Well, in your presentation, representing the output, the view as a model of the input is not correct. Yeah, because you are neglecting the model. Yeah?
Which one? Which slide?
It was when you had a function, the output is a model of the input. No, it was in the former slide.
This one? No.
Yeah, maybe this one. Yeah, you're neglecting here. You're neglecting the data. Yeah, but normally you have the output. Of course, is dependent on the state. Yeah, on the model.
Yes, exactly. But my state is in. Well, in the input, I mean only the input which is generated by the user, right? Input in this case, it's like all interactions made. If we take the web pages, it's about interactions with the DOM, right? I'm not sure if this responds to the question, but
when you have such a function, so that you have the user input and you produce the output. But normally the output is dependent also on the model, on the data, yeah?
Yes,
on
exactly.
the database or
yes, exactly.
whatever, yeah?
Exactly.
So this is not correct. It's not a function of the input of the output. That is a function of the input, the state, and produces the output.
Yes, that's correct. This is some sort of like short, yes?
So actually you hide the state to the streams.
Yes. So my state is in this main function. And as you said, it's a combination. I take I produce the output based on the input, but also on the state, which I happen to gather through observables. Any other question? Yes?
Now that Angular 2 is thoroughly adopting RxJS, what do you see as being the sort of the future for Cycle?
Interesting question. I run this conference called PolyConf, and one of the reasons is that I believe that there is room for everything. It's not that we will all use Angular, right? And I think it's interesting to always look outside of our domain, like our domain of expertise, outside and take ideas and get inspired by them. So I think there's room for both. Obviously, the migration path from Angular 1 to Angular 2 is like large corporations now use Angular 1, so they will probably migrate towards Angular 2. But this is interesting in the sense that for many people, this may be a new way of thinking about the UI. And I really like it. So as I said, this is some kind of excitement I wanted to share with you. And so there is room for both, in my opinion. Any other question? Yeah.
And have you compared Cycle.js and Elm?
Excellent question. So Elm and Cycle.js are very close. But what I like I like both. I think Elm is excellent tool, excellent programming language. But what I like here in Cycle.js, it's JavaScript, right? So it's already something we all know. And the migration path or like adoption path is simpler here. But we can use Elm if you're Yeah.
If I just can add to this question. Because I discovered Elm a few months ago with a friend who were a group of us, and he showed us how to use Elm. And I actually also saw Cycle.js a while ago, and so I played a bit with Rx, and I found out that Elm is much easier to understand. If you're coming from a JavaScript background, it's much easier to start with Rx and understand how streams works, and then try Elm. It will be much, you will get it almost instantly because you already know the streams and observable parts. So it can be like a learning curve thing. If you're comfortable with JavaScript, I think it can be a good first step.
Yeah, I agree. Other questions? Okay, so you can catch me later if you have more questions. Thank you very much.